XOXO, XOXO, XOXO.
Assalamualaikum warahmatullahi wabarakatuh. Hello guys, my name is Putri Alivia. You can call me Putri. I am from Department Fisika A 2019. In this time, I will description about the map of Physics. So, Physics is a huge subject that cover many different topics, going from galaxy in the depths of space, right down to subatomic particle. And if you don't already know Physics, it's difficult sometimes to see how all these different subjects and are related to each other. So this is my attempt to show that in a map. Okay, map a physics. I hope you enjoy it.
Physics can be broadly broken down into three main parts: classical physics, quantum physics, and relativity. We will start with classical physics, and a good person to start with is Isaac Newton. His law of motion describes how everything made of matter moves about, and his law of universal gravitation tied together the motion of planets in the sky with the falling of objects on Earth into one elegant and general description. He also invented calculus, a supremely powerful mathematical tool which has been used over the centuries to derive new physics. Calculus really part of mathematics, but physics and mathematics are inseparable. Math is the language of physics. You can imagine in like the bedrock that the world of physics is built from. Newton also made strides in the field of optics, which is the physics of light and how it travels through different materials. It explains refraction, seen in prisms and lenses, which are used to focus light in telescope, microscope, and camera. Telescopes enable us to peer into the depth of space and observe the wide array of objects, and develop astronomy, astrophysics, and cosmology. Optics is closely related to the theory of waves, which is basically how energy can travel through the straps of a medium like ripples on the surface and of a pond or stone through the air. Light doesn't need a medium to travel through. It can travel through the vacuum of space, but it still follows the same principle and as wave, namely reflection, and diffraction. This is led us to electromagnetics, the description of magnets, electricity, or more generally electric and magnetic fields. It was a physicist called James Clerk Maxwell who discovered that there are two aspects of the same thing in derived the wonderfully elegant rules of electromagnetics and theory that light was electromagnetic wave. Electromagnetic also explain all of electricity. Jumping back a little bit, classical mechanics is related to Newton's laws and governs the properties and motion of solid objects, how they move when force hit them. What happens when they are joined together, like in girders of buildings or bridges. Fluid mechanics is the description the flow of liquids and gases. Using fluid mechanics, you can work on how much lift is generated from an aeroplane wings, or how aerodynamic a car is. Fluid mechanics is notoriously difficult, mostly because motion of tiny things, like molecules, get really complicated really fast, which leads us to cause theory. Cause theory is the description of large complex system and how small differences in initial condition can lead to very different final outcomes. Theory dynamic is the description of energy and how it passes from one form to another. It also includes entropy, which is a measure of order and disorder, and basically tells us how useful different kinds of energy are. Energy is fundamental property to physics, and although I have written energy here, I should have written it everywhere on this map because everything has energy. So that is all of classical physics, the picture of the universe we had around the year 1900. It told us we live in the universe where everything runs sort of like clockwork if you could measure everything accurately enough. The future was kind of predetermined. However, not everything was solved. There were just a few of holes in experiment that hint at something more. The orbit of Mercury was likely to fast and some strange things happened. On the small scales with electrons and light which we are unexplained. Physicists at the time thought that they would solve and explain this problem soon enough. But at the time, the unraveled the new domains of relativity and quantum physics and turned our understanding of the universe completely on its head. Albert Einstein was the genius who developed the theories of special and general relativity. Special relativity predicts that the speed of light of constant form all observed, which meant that when you travel really fast with stuff starts happening like them slowly down. It also states that energy and matter are different aspects of the same things through the famous formula E mc squared. General relativity says that space and time are part of the same fabric called spacetime, and that the force of gravity comes from objects bending spacetime, making other objects fall in towards them, while relativity describes the very big. Other physicists will busy and work on the very small. In the world of quantum physics, atomic theory probed and nature of atom and more detailed description of the atom were developed, from a tiny sphere to electron orbit to energy levels and to the electrons being wave-like charge distribution. Condensed matter physics describe the quantum physics of many atoms together in solids and liquid, and is where many great technology have come from, like computer, laser, and quantum information science. Nuclear physics describe how the nucleus of atom behave and explain radiation. Nuclear fission, the splitting of the atom used in our nuclear power plants, and nuclear fusion, which takes place in the sun and will hopefully soon be harnessed here on Earth. Particle physics probes even deeper to find the fundamental subatomic particle that everything is made of and are described in the standard model of particle physics. Quantum field theory captures all of quantum physics and combines it with the special theory. of relativity and is the best description of the universe we have. Unfortunately, quantum theory doesn't include relativity, and so physics don't know how to join together quantum physics and the general theory of relativity leading to the giant case of ignorance. One day in the future, we hope to close these camps and come up with a theory of physics. We call it quantum gravity, and there are many attempts to do this. Some example are string theory or loop quantum gravity, and there is many more. But quantum gravity doesn't the only thing we observe but don't understand. They are also the major puzzle of dark energy and the dark matter, which seem to make 95% of universe, so all of our physics only really describe 5% of what we know about, and everything else at the moment is a mystery. There are many other mysteries out there like the Big Bang guys, and no doubt there are things beyond that we don't even know that we don't know, which gets to the lovely cult which fall over all of physics philosophy. Although, although many physicists make fun of philosophy, it is the big philosophical question that motivate a lot of physics, like what is fundamental nature of reality? How come the universe even exists? Do we have free will if we are just made of physics? Or how do we know that the way that we do physics and science actually gets to the fundamental truth of the universe? And just why is all of physics like the way it is? Well, those are the big questions, one which we may or may never answer. But is no reason to give up trying. After all, physicists are not quitters, and was the map of physics. So that's the end. Thanks for watching my video. I hope you enjoyed. Don't forget to like, comment, subscribe, and share. Okay guys, thank you. Bye-bye. Assalamualaikum warahmatullahi wabarakatuh. See you next time.